Alright, let's talk about a linked list cycle too. So you are given the head of the linked list and return the node where the cycle begins. And if there's no cycle, return node. Alright, so in this question is pretty standard and then it's pretty famous. So how do you actually solve this one? You can actually use a two-pointer. So two-pointer represent what? Fast and slow, right? Fast and slow. So fast, you're moving twice step per time. And slow is moving one step per time. So I'm going to just basically declare my fast and slow at the beginning. And then I will just what? Jump twice. So I need to check my current, I need to check my condition. Is my fast equal to no? Is my fast on x is equal to no? If they are not, you can move your fast and move your slow. Alright, so slow is moving once, right? So you will just erase this and then jump to here. And I will erase the old one. And then let me just change another color. So fast is what? Jumping twice, right? So this is fast. So they are not the same at the same position, right? So you're moving your slow here, and you're moving your fast twice, right? 1, 2, back here. Oh, fast, and they are not, right? So you want to move two nodes together. So you need to check at the end if they are the same or not. You cannot just move one pointer and then just see if they are the same, and then if they are, and then you will return. This is not correct. You want to move your fast and slow in a complete iteration, and then you can check if they are the same or not. So once again, this is not the same. So you're moving your slow by 1, slow. You're moving your fast, jump 2 times to over here, right? Fast. Now you know they are actually what? In the same node, right? Now you want to move your fast or your slow. Either one of them back to the head. So either one of them back to the head. And then you are moving one time at the same time. So let me just take my slow out. So you are moving slow, one step for each iteration, and moving your fast one step for each iteration. So you will come here, and then they are actually meet, right? So this will be the condition where it's a cycle. So how about if they are not a cycle? If they are not a cycle, just imagine this is not here. So you're moving fast and slow at the same time. So let me just change another color. And then fast, you're jumping from here to here, right? And slow, jumping one step. Oh, just imagine this is not here, okay? This is slow. So they are not the same, so you're moving again. So for every single time, you need to check, is my fast is not no, or fast up next is not no. If this is true, then you can jump. If this is not, you want to break out a while loop. So the current position is not it's not no, right? The current position dot next is not no. Then you can move twice step. So which is here. Now the fast is what? Is no. And you need to also move your what? Slow. Alright, so you will break out the while loop. Then you need to check the condition. Is my fast is actually equal to no, or fast on next is equal to no. If this is true, then you know this is not a cycle. This is not a cycle, so it is this condition. So it's pretty much like the opposites of condition in the while loop. And this is the solution for two-pointer. And then just stop coding. So list node fast equal to head, slow equal to head, and then while fast is not no, and fast on next is not no. You can say fast equal to fast on next dot next, 2 step, right? Slow equal to slow dot next, and you check the fast and slow. If they are the same, then you break. So if this is not a cycle, right? This is what? A cycle. If this is not a cycle, it's going to be what? If fast is equal to null or fast.next is equal to null, then you know this is not a cycle, you return null. Alright, so once this is a cycle, once this is a cycle, you need to what? Move your pointer back to the head and then move one time per time for each one, right? So slow is not equal to fast, so slow equal to slow.next, fast equal to fast.next. And in this condition, you can return slow or fast, but in my case, I want to return slow. They are actually at the same position, so it doesn't matter. And submit. Alright, so for the time and space, this is pretty straightforward. This is going to be all of them for the time. You need to move, every single time. And it doesn't matter if it's like n over 2 or what, because you actually jump twice, right? So it's still going to be all of them for the time. And for the space, it's constant, right? So this is the 2-pointer solution. Now let's talk about the next one. The next solution is going to be using the set. So since this is the what? This is a listener, right? And then there is an address for the listener, and I will just traversing, and then if they are actually at the same position, I will be able to what? I will be able to know like they actually meet, right? And then I will just return. So once again, let me just do the demo. So this is a set, and I only have one pointer in my case, right? So I will add 3 into the set. Now 3 is not in the set, right? So I add it, right? Now I move my pointer the next. So now I add 2 in here. 2 was not in the set, so I add, right? Now I need to check, is 0 in the set? No, then I add some. So it's right here, right? Now I need to check, is -4 in the set? No, right? I need to add and then move. Now is the 2 is in the set? Oh, 2 is in the set, then I can actually what? Return the node. And if there is no cycle, then you keep going until the node, you break out a value. So this is a condition, and you are not putting the value, you are actually putting the listener. So follow my solution. Set listener set equal to new hash set, while head is not null. So if the set contains the current position, which is head, you will return head. If not, set.add the head, and also you're moving your head to the next pointer. And if you break out the while loop and this is not a cycle, you will return null. So it's a little bit straightforward, but whatever, right? So let's talk about the time and space. This is going to be all of n, right? And this is all of them for the time, right? This is pretty straightforward. All of them for the time. This is all of one contains, and using the hash index for the add. So all of one. So total is all of n for the time. This is all of n for the space, right? You add in every single listener into the set. So this is a solution for 2-pointer and a hash set. So if you have any question, leave a comment below. Subscribe if you want it. Alright, peace out. Bye.